Okay, so I just few brief things about the magnetic field. So symbol for magnetic field is letter B, and we say it's the area around a magnet. So for example, if you have a magnet like a bar magnet and you place some iron filings or some other nails or things like that, they will be attracted towards the magnet. So all this area around the magnet is called the magnetic field. And so unit for magnetic field is Tesla, like Tesla cars. And then there are smaller units, millitesla and microtesla. So lines of magnetic field can be drawn around the magnets as shown in this diagram. I will show you another diagram in a minute. So these lines of magnetic field tell us what is the size of the magnetic field at some position around the magnet, or what's the direction of the magnetic field. So if there are more lines, so say for example, I will just show you this diagram. Now, this one is lines of magnetic field are evenly spaced. So we say it's a constant or uniform magnetic field. However, in this diagram, there are more lines of magnetic field in this area. So we say that magnetic field is stronger here, whereas somewhere over here, magnetic field is a bit weaker as compared to this one. So if you look around the magnet, so there are more lines of magnetic field that come out of the South Pole or the North Pole. So that's where the magnetic field is strongest. If we look at the direction, you can see that these arrows are coming out of the north. So lines of magnetic field come out of the north and they go into the south. So if you place a compass, it will be pointing out in this direction. Or if you place a compass somewhere here, it will be pointing towards the South Pole. And if you look inside the magnet, then inside the magnet, lines of magnetic field go from south to north, whereas outside they go from the north to south, making like complete loops like that one. So there are, always remember, magnetic field goes from north to south. So these are two different magnets, North Pole and the South Pole. Uniform magnetic field, a little bit weaker magnetic field here because it's not evenly spaced. Okay, there are some diagrams here where you will have to kind of look at these one and answer these questions and answer those questions. I wouldn't spend too much time on that one. There are some answers down at the bottom of that page also. So I will take you to the next. Is everyone all right about magnets and magnetic field? Just a quick revision. Yes. Yeah. Okay, that's good. That's good. Okay. Okay. Now, does everyone see the new kind of set of notes? Magnetic field of a current carrying wire?
Yeah.
Okay, good. So, and not only that there is a magnetic field around a magnet, but there is a magnetic field around a current carrying wire. And this magnetic field is directly proportional to the current. So that means if current is stronger, current in the wire is stronger, magnetic field will be larger. But magnetic field is inversely proportional to the distance. So somewhere over here, magnetic field will be weaker as compared to near the wire. That's where the magnetic field will be stronger. And this is a constant. That value will be given in your booklet, and pi is also constant. So these just numbers are constant. So it's directly proportional to current and inversely proportional to the distance. If we look at from the, so this is the side views. If we look from the top, that's how it looks like, okay? So if you say, so say for example, imagine a wire is coming out of the page. So we give all the directions with reference to the page. If wire was coming out of the page, so we represent it by a dot. If the current is going into the page, so there's a wire that is going into the page, and that's the direction of the current going into the page, we represent it by a cross. And lines of magnetic field can be found by using this, what we call as the right-hand grip rule. Okay, and right-hand grip rule is like that. So if you imagine you're holding the wire in your right hand, your thumb should be pointing in the direction of the current, and then your fingers curl in the direction of the magnetic field. Okay, so let's look at a little bit of animation here, which is given there. Okay. Now, does everyone see a new kind of screen with the yellow background?
Yeah.
Okay. So in this wire, these tiny, these are electrons which are moving downwards, but the current, which we always use the direction of the conventional current. So current is going upwards with the red arrow. So if you imagine that you're holding this wire in your right hand, you can actually take out imagine you're holding a pen or something in your right hand, then, like it's this one. So your thumb should be pointing in the direction of the current upwards, and then your fingers are curling. So what directions do your finger curl? They're curling anti-clockwise, isn't it?
Yeah.
Okay. So is everyone sure? Like that? And your fingers are curling and looking from the top, they're curling in an anti-clockwise direction. Now, if you place a compass here, first of all, is everyone with me?
Yeah.
If you place a compass here, okay, so compass will tell you the direction of the magnetic field. So just behind the wire, so the red part is the north of the little compass. So it is pointing in the direction of the magnetic field, which is anti-clockwise. So it is pointing to the left. Somewhere over here, exactly over here, it is pointing. It is coming out of the page. Okay, so if we say that this direction is up the page, then this is out of the page. So if I take this compass here, so lines of magnetic field are to the right of the page. And then if we look over here, that they're going into the page. And again, as you can see, that further we go, magnetic field is weaker. So lines of magnetic field are further apart, and closer we come, lines of magnetic field are nearer. Now, just leave this here. Now let's change the direction of the current. So make it reverse the direction of the current. So you can see electrons moving upwards. Now, what's the direction of the current? Down the page. So we look everything with reference to the page. Okay. So now, again, if you take your pen and you hold it in your right hand, so the pen is pointing down the page and your thumb is pointing in the direction of the current like that, and you look from the top, then your fingers will be curling in a clockwise direction or anti-clockwise direction? Can anyone tell me? Clockwise, good. So fingers are curling in the clockwise direction. And again, we can see that from this animation also, that they're curling in the clockwise direction. So can anyone tell me, what's the direction of the magnetic field that this compass is giving us? And we say into the page, out of the page, right, left, or up and down.
Is it into the page?
No, it is coming towards you, isn't it? So the red arrow is towards you, so it is out of the page.
Right.
Okay, if it is here, then what direction is the magnetic field? To the right or to the left? Where the red is pointing, to the left. Is everyone sure? And then over here, what direction is the magnetic field? Is it out of the page or into the page? What direction is this red arrow pointing? Caroline? Into the page. So over here, it's into the page, whereas, and then behind here, it is to the right of the page. And again, if we keep doing it, so that's out of the page, to the left, and so on. Okay, now, where is my, just give me 1 second, there's too much sunshine. I'm sorry, girls. Okay, so now let's go back to my notes.
Me llamo Tokio. Pero cuando comenzó esta historia, no me llamaba así. Estoy pensando en irme de viaje.
Okay, so I'm back to the screen. So, and this kind of, there is an exercise that you have to do from your booklet. And so will you note down that you have to not only do question 1 to 4, page 6 is page 6, but you also have to do questions 9 and 10 from the booklet. And there are some detailed note also, which I've given you the link. And you know what, when we were talking, yeah. Yes?
Yeah.
Any questions?
No.
Okay, you know, this diagram also explains it a little better. So current is going up the page. And if we use the right-hand grip rule, so this one is like in a anti-clockwise direction. So these are the lines of magnetic field, which are in an anti-clockwise direction. So somewhere over here, lines of magnetic field are coming out of the page. So a dot represents out of a page, a cross represents into the page. And over here, you can see the similar thing. Arrow is saying that, you know, it's like the compass pointing, so it's pointing this way. So it's coming out of the page, there is going into the page. Okay, so, and this diagram also tells you, and remember the current always comes from the positive of a battery. So it's going into this direction like that. So if current is in this direction, so again, if you put your hand to the right of the page like that, imagine you're holding a pen or something and it's pointing to the right of the page like this one, then your fingers are curling and they're coming towards you, as is shown in this diagram over here. So those will be the directions of the lines of magnetic field. So over here, it will be coming, magnetic field is coming out of the page. Somewhere over here, it's down the page. Somewhere over here, it will be into the page. And just behind this wire, it will be up the page. So basically, that is just explanation of these two lessons or these two kind of notes that you've seen on the screen. Any questions, girls?
No.
No, it's all right. So, and so in the notes over here, there are some, you know, like there's video which you can watch, this applet that you can explore, and there are some detailed notes, and there are some you can actually read. So if there are no more questions, so that was all from me. So I will let you get on to your today's work. And can I just remind you again, those, if you haven't handed in your assignment for static and DC, please do that. And any questions, girls? Okay, we're back into this one then. So if there's no questions, so I will end the meeting now. So thank you for joining in again, and good luck for this week's work. I will also be posting 2 more, you know, like there will be altogether 4 lessons, and I will be posting those lessons. So thank you, and all the best for this week.
Thank you, Miss. Have a good
Thank
day.
you. Thank you.
Okay, bye-bye.